So today we're going to look at using the TI-84 to run a hypothesis test for a population mean. Now there is an online calculator that I posted on Canvas that you can also use. I'll be showing a video on how to use that as well, but this is going to be focused on the TI-84. And it's actually pretty simple. So let's take a random sample of 60 second graders. Now is that enough? Yes, so we're random and 60, so N is 60. In a certain school district are given a standardized math test. The sample mean score is 52. Assume the standard deviation of the test score for the population is 15. Still a little fuzzy, sorry. The nationwide average on this test is 50. The school superintendent wants to know whether the students in her school district have greater math skills than the nationwide average. So, remember, the null hypothesis is always the status quo, the average. So the null hypothesis would be that the average is still 50, that the mean is 50. The alternative is that the mean is greater than 50. She wants to know if her students have a greater math average than the population. So we got to verify a few things. Do we know that we have a random sample? Yes. Do we have a normal distribution? No, but is our sample size larger than 30? Yes. Check. Now, to find the test statistic and the p-value, we are going to be using technology. So we are going to use the TI-84. So I've got mine handy. I'm going to press Stat and then go over to Tests. We are performing a z-test. And we can either use data. So if we have our data in a list, we would choose data. If we are going to be using statistics like we are, we're going to choose stats. Now, this mean sub 0, that's the value from our null hypothesis. So maybe we should write down what we have. So we're doing the z-test. And we're putting in stats. And the mean sub 0, that's going to be 50. That's our null average. And then it has standard deviation. Let's see, that was 15. And then it has X bar, so it wants to know what the sample mean was. Well, she said the sample mean for her school is 52. And then N, how big was the sample size? It was 60. And then we have to choose which test we're running. Is our alternative not equal to the null, less than, or greater than? Well, it just happens to be that it selected the greater than automatically, but we would, if we were doing a less than test, we would select there. Not equal to would select there, but we're doing a greater than the null. So this is the one we're going to select. And then we can either have it draw the picture for us, show us that region, which I might go back and have that draw it for us, but we want to calculate the values. And so it gives me my z-score, my test statistic. It gives me my p-value. And we need to decide whether the result is statistically significant. So the way we make that decision is we compare it to the alpha which I'm looking to see if they gave it to us. They did not. They would have to give it to us, so let's assume that alpha is 0.05. And we're going to have to go with that. So if our p-value is less than that alpha, that means we will reject the null. If our p-value is greater than alpha, we are going to fail to reject. So we're comparing those two values. So which one is it? Well, 0.15 is bigger than 0.05, so 0.15 is bigger than 0.05, so p is bigger than alpha. We will fail to reject the null. So the way we would report this is that there is not sufficient evidence I can't spell evidence to say that the mean is greater than 50. If we go back to the court case, we don't have sufficient evidence to say that the mean is no longer 50. It's still 50 according to the courts.